Hey guys, welcome back to my channel. I am Karthik Agrawal, who is currently studying in Sri Venkateswara College of Engineering. I hope you have understood from the animated video. Today we are here to talk about normal distribution. In today's video, we will take a deep dive into one of the most fundamental concepts in statistics, the normal distribution. Whether you're analyzing test scores, heights, or measurement errors, the normal distribution is a tool you can't ignore. Today, we'll break down into simple terms, cover key concepts like standard tendency, standard deviation, and even walk through real life examples. So, let's get started. First, let's understand what is normal distribution. The normal distribution is a symmetrical bell-shaped curve that shows how values are distributed. Most of the data points cluster around the center, called the mean, while fewer data points appear as you move away from it. It is defined into two key parameters: the mean, which represents the central point, and the standard deviation, which measures how spread out the data is around the mean. Now, let's understand by thinking about an adult height or average test scores. Most people fall close to the average test with fewer outliers at the extreme. Understanding this curve helps us to analyze trends and make predictions. Now, let's understand central tendency and dispersion. Central tendency refers to where the data clusters in a normal distribution, the mean, the median, and the mode all align at the center, whereas dispersion describes the spread of data which is captured by the standard deviation. Y- When the standard deviation is small, the curve is taller and narrower, showing less variation. With a larger standard deviation, the curve flaunts and spreads wider. These insights help us to understand the consistent or variable the data is. Now let's understand the role of sample size. When we work with small examples, data can appear irregular or skewed, but as sample size increases, the data starts to smooth out the resemblance or true normal distribution. Typically, once your sample size exceeds 30, the distribution stabilizes and becomes more reliable. That's a very large sample size and critical in research. They reduce variability and increase accuracy. Now, let's understand non-normal data. Not all data fits neatly into a curve. Some distributions are skewed, meaning most of the data clusters to one side. For example, income levels or dental DMFS scores often show skewness because extreme values put a curve in one direction. Even though these data sets are normal, we can still analyze them using transformation or specified statistical method. Now, how do we know if a data follows a normal distribution? We can use tests like Scarpio-Walk or Angus-Darling to check the if your data is normal or not. If your data isn't normal, don't worry. There are workarounds you can transform the data to make normal or use parametric methods that don't assume normality. These tools are essential for ensuring the accuracy of your data. Now, let's understand this real life example. As you can see the question, most graduate schools of business require applicants for admission to take graduate management admission council, that is GMAT examination. Score of the GMAT are roughly normally distributed with a mean of 527 and the standard deviation of 112. What is the probability and the individual scoring of above 500 on the GMAT? Here, as you can see, they have given the mean that is 527 and the standard deviation of 112. So now first let's find the z value. As we know, z is equals to x minus mu divided by rho, that is expected mean minus actual mean divided by standard deviation, where x is 500, mu is 527, and rho is 112. Hence, z value is nothing but minus 0.24. Looking up to the z-score in the table tells us that 40.52% of scores fall below 500. To find the probability of scoring above 500, we subtract 1, giving us 59.48%. This analysis is visualized on the graph. The shaded area represents scores below 500, while the unshaded area represents the 59.48% chances of scoring above. This is how normal distribution helps us to make informed predictions in the field like admission and hiring. Before we wrap up, let's recap the key points. The normal distribution is symmetrical and defined by mean and standard deviation. Large sample sizes produce more reliable and smoother distributions. Not all data is normal, but we can analyze it by using specialized methods. Practical applications like GMAT scores show how normal distribution aids in decision making. Understanding the concept is invaluable whether you're a student or a researcher. That's it for today's section on normal distribution. If you found this video helpful, give us a like, subscribe for more content, and drop comment with your questions or feedback. Thanks for watching. I will see you in the next one. Thank you.